We will now change our strategy and change our network architecture. So instead of using fewer layers and more nodes, we will use fewer nodes and more layers. So we'll do what is something like a deep function approximator. So instead of having a relatively flat network with only 3 layers, we can now distribute our nodes over more layers, each containing fewer nodes. In this way, we obtain a more narrow and deeper network. So in this example, we can use 5 or 4 layers, but each layer will only have 2 nodes. So our pytorch implementation is basically the same. We're just defining more layers and changing. So we are using 2 nodes, and then we have 4 layers, and the output layer, again, we have the activation function after each layer, but we don't have any activation function after the last layer. And we'll do the same. It's the same input and target for the training set, and the same input and target for the validation set. We will use the same loss function and the same optimizer. We'll just increase now the number of epochs, and we'll run our model, and here we see that it turns out that the Adam optimizer now needs more interactions instead of just the 10,000, so we needed 15 times more, but the resulting function approximation seems to be more smooth. So this is an advantage for the generalization, and we observe that the validation set now has a very similar loss when compared to the training set. Here we have our plot, and we have in blue our target, so it's a sine wave with the noise. Then the prediction, so we see it is smooth, and it's robust for against noise. And the optimization has a harder time to fit the function despite the 15 times more iterations, but often it is found that deep networks are better for generalization, which should give the loss for the validation and test similar values as for training. Here we are now plotting the validation set, so we have the extrapolation of not only one cycle but 2 cycles of the sine wave. And we see that we have reasonable interpolation, but again, doesn't do a good job on extrapolation. And again, we see the basis function of our networks. So those were 2 different ways, and we tried to approximate a function. We took care of interpolation, and we saw that it's not a very this architecture doesn't show good results for extrapolation, so we need to think about some different approaches on how to do this extrapolation.